Negative exponents. We have two definitions to help us simplify expressions with negative exponents. X to the negative n is equal to 1 over x to the positive n. So if we have a negative exponent, we can shift it to the denominator and make the exponent positive. And the second one, 1 over x to the negative n, is equal to x to the positive n. So if it's in the denominator with a negative exponent, we can shift it to the numerator and make the exponent positive. Let's look back for a moment and see why we need a definition for something to a negative power. Let's go back to positive exponents for a minute and say we look at 2 to the third. Right. This has a nice clear meaning. It means take 3 copies of the base. And then we can work it out. But what if we try to make a negative number of copies? How do we make negative 3 copies of the 2? We can't. So this is why we need a definition. It doesn't fit with our old definition. Let me show you a little bit of why they make it this particular definition, an example of where it comes from. If we look at a problem, say x to the third over x to the fifth, and we can write those out to see the picture of what this means. It means 3 x's on the numerator and 5 x's on the denominator. And once you have products, you're allowed to divide out common factors. And so I have 2 x's left in the denominator. Remember, if everything divides out of the numerator, then it's a 1. You have to write the 1. So we know this is the right answer to this problem. The picture does not lie. If we try to use our subtract rule for exponents, we would have 3 minus 5 would give us x to the negative 2. So this would be where a negative exponent is showing up. We want it to have the same answer as the problem it comes from. So this is going to equal 1 over x to the positive 2. So to work with it, you can just shift something with a negative exponent to the opposite place. If it doesn't show a denominator, then it's automatically in the numerator. Shift it down, change the exponent to positive. In general, we want to write expressions with positive exponents, with the exception of scientific notation. So if we have an expression with a negative exponent, notice the word negative and exponent, it can be shifted to the opposite position and the exponent changed to positive. You always have 2 changes. So something has a negative exponent, it's going to shift. If it's down, it goes up. If it's up, it goes down. And the exponent will change to positive. Let's look at some examples. First, we have simplify x to the negative third power. This one is just a direct application of our definition. So we're going to rewrite it. We're going to shift this x to the negative third to the denominator. The exponent becomes positive. For our next example, we're going to simplify a to the fifth times x to the negative 2 power. You want to make sure that you only move the right pieces. So there is no reason to move the a. It has a positive 5 for an exponent, so it is going to stay. The one that is a problem is the x because it has a negative exponent. So we're going to make a fraction form. The a is staying in the numerator. The x is going to shift down, and the exponent changes from negative to positive. For our next example, simplify x to the negative fifth over y to the third. The x is the piece that's no good. It has a negative exponent. So it's on the numerator. We're going to shift it to the denominator. The y is fine. It has a positive exponent, so we're going to leave it where it is. So the x is going down, gets a positive exponent. The y is staying. And I just kept them in alphabetical order. That's why I put the x first. Remember, when everything goes out of the numerator, you have to show a 1 so that you see it is still in fraction form. For this example, notice the x to the negative 2 is in the denominator. This is the piece that's no good. Your constant is fine. It is down, so we're going to shift it up. The 6 is staying. The x shifts. The exponent becomes positive. When everything shifts out of the denominator, you are not required to write the 1 in the denominator. Our next example, simplify negative 3x to the negative 2 over y to the third. There is only one piece in this problem that is no good, that will need to shift, and that is the x to the negative 2. It has a negative exponent. The negative 3 is fine. It is a constant, not an exponent, so we don't shift it. So we're going to keep the negative 3 and the y to the third where they are. And the x was on the numerator, so it's going to the denominator, and the exponent changes to positive. Next, we will simplify 5 to the negative 2 power. You cannot do any evaluating here. We cannot make negative 2 copies of the 5. So first we have to use the definition and change it over to a positive exponent. So right now it's in the numerator. We're going to rewrite it. Shift the 5 to the denominator and make a positive 2. So we have to show a 1 in the numerator. So 1 over 5 to the positive 2. Now we can work it out. 5 squared does have a meaning for us, but it is in the denominator. 5 squared gives us 25. So remember, shift this first before you try to evaluate. There are two approaches to this next problem. I'm going to show you both, and you can try and see which you prefer. It doesn't matter. One is as good as the other. One thing we could do is we could use our old rule. We have like bases as a fraction, and our rule was keep the base and subtract the exponents. If you're going to use this rule, you should write it out so that you don't make a sign error. Negative 2 minus for the rule, a negative 5, and then you'll clean up. Minus a negative makes plus. Gives us x to the positive 3, so it stays on the numerator. The other approach to the problem is to shift first. We already have a fraction form, so shifting is not going to make it any more complicated. So we have a negative exponent. This one's on the numerator. It's going down. This one has a negative exponent, so it is going up. So now we have x to the 5th on the numerator and x to the positive 2 on the denominator. You still have like bases as a fraction. You're going to keep the base and subtract the exponents. But it's easier to subtract the positive ones in your head. Go top to bottom when you use the subtract rule. So 5 minus 2 gives us 3. So x to the third. So you can use either one that you like. Basically, when I have two approaches, if I already have a fraction form, I don't care. I'll use either one. If it's not in a fraction form, I tend to save the shifting until last. Here is one more problem that we'll look at with two approaches. It is in a fraction form, so it doesn't really matter which I do first. This is like three little problems all put together. So I have my numbers, I have my x's, and I have my y's. So first I'll just use our old rule, our subtract top to bottom for a fraction. Remember, for numbers, you do plain old reduce, and we only have one negative, so it's going to be negative. It does not matter where you write the negative. And we have a common factor of 2. 2 goes into 2 one time, and 2 goes into 10 5 times. For the x's, we're going to subtract. Remember, subtract top to bottom. So we have 5 minus a negative 2. Minus a negative makes plus, so we get x to the positive 7. When you use the rule, it goes on the numerator. Then we'll do the y's. Y to the negative 4 minus for the rule, a negative 3. Clean up, minus a negative makes plus. You get y to the negative 1, which is going to make it go to the denominator. So you get 1 over y to the positive 1, or 1 over y. So we're okay up here. We don't have to write the 1. We have something else there, the y. And if you have something in the numerator, you want to recognize it without this other 1. You don't need the 1. 1 times x to the 7th is still x to the 7th. So you would want to recognize this as an equivalent answer. The other way to do the same problem is by shifting first on the pieces with the negative exponents. So the y to the negative 4, the x to the negative 2, and the y to the negative 3 are the pieces that I'm going to move around. Keep my fraction form. My constants stay. My positive exponent stays where it is. This x is going up, and it gets a positive exponent. The y's are actually just going to switch places. The 4 is coming down. The 3 is going up. And now we'll work with what we have. We have numbers, we have x's, we have y's. So first of all, for the numbers, we'll reduce. We only have one negative. That's odd, so it's going to be negative. We have a common factor of 2. So divide by 2. 2 into 2 goes 1 time. 2 into 10 will go 5. For the x's, they're side by side, so keep the base and add. So that's x to the 7th. For the y's, you're going to subtract. 3 minus 4 gives us y to the negative 1, which makes it go to the denominator and get a positive, so it will be 1 over y. We already have something on the numerator, so we just have to put the y in the denominator. And then you will want to recognize it without this 1 because you have something else in the numerator. So this is an equivalent answer. And we did get the same answer as we did before. So if I have a fraction form, it doesn't matter which order I apply the rules. If I don't have a fraction form, I tend to go with the old rules first rather than getting a fraction. For this next example, notice I do not have a fraction form. So I'm going to save any shifting until last. Getting a fraction makes it a little bit more complicated. So I can use my old rule of like bases multiplied, keep the base and add the exponents. And I have like signs, so I'm going to add and keep the sign. Then I'll deal with the negative exponent. So it's a negative exponent. I'm going to shift down and make the exponent positive. For this example, I can use my product to a power rule. So we're going to take this exponent and apply it to each piece of the product. So we have x to the 5th to the negative 3rd, and we have y to the negative 2nd to the negative 3rd. And remember, power to a power, keep the base and multiply on the exponents. So I get x to the negative 15. And on the y, notice you have two negatives. That's going to give you y to the positive 6. And now I'll deal with any negative exponents. So only the x is no good. So right now they're both on the numerator. So the x is going to shift, go to the denominator. Its exponent becomes positive. And the y to the 6 stays on the numerator.